Everything we've been coding so far has been stuff you have built yourself. So you can see exactly how it works and exactly why it works, and then reuse that code in your other projects. Sometimes though, writing everything from scratch is a bad idea. In fact, a risky idea. Perhaps the code is complex. Perhaps easy to get wrong. Perhaps it changes very often, or any other myriad of reasons. Which is why dependencies exist. The ability to pull in third-party code someone else has written, into your projects and use it there. Now, Xcode comes with a dependency manager built in called Swift Package Manager, or SPM for short. You can just tell Xcode the URL of some Git repository on GitHub, for example, and it will download it for you. You can even tell it which version to download, which means if the remote code changes somehow in the future, it won't break your project. To try this out, I've made a sample Swift package ahead of time you can put into any project. And this thing adds a very small extension to Swift's sequence type, the protocol, which array, set, dictionary, even ranges all conform to. And it'll pull out a number of random items. So when you're saying random element again and again, you get 5 random elements back, for example. Anyway, the first step is to go to Xcode's file menu and choose Add Packages. And then up here, you can enter a package URL. You want to look for https://github.com/2straws/sample package, like that. github.com/2straws/sample package, and then it will scan it and download it and show you the little README here. And you have options to customize what it does, and it's very, very nice. It's very, very nice here because you can choose exactly what the dependency rule is going to be. And you can see it defaults to up to next major version, which is the most common one to use. And it means if the author of the package, me, updates it in the future, then as long as they don't introduce breaking changes, Xcode will automatically update the package safely for you to use the new versions. Now, the reason this is possible is because most packages use a versioning system called Semantic Versioning, also called SemVer. And if you see a version like 1.5.3, then 1 is the major number, 5 is the minor number, and 3 is the patch number, 1.5.3. And if developers follow SemVer, the rules of SemVer correctly, then they should change the patch number when fixing a bug, as long as it doesn't actually break any APIs or add any new features. They should change the minor number when they add features that don't break any APIs, and change the major number when they do break APIs. And so up to next major version works brilliantly because it means you'll get new bug fixes and new features over time, but won't accidentally switch to a version that breaks your code. Won't happen, in theory, as long as they follow SemVer exactly. Anyway, we're done with this thing now, so go ahead and press Add Package. And it'll download and import it and think about it and da-da-da-da. And eventually, when you press Add Package, it will now be listed in your packages thing here in your project. So it's there, it knows I'm using sample package. We can go ahead and start using it over in Content View. We can bring an import in. So I'll do import sample package. That's my module now. It's an external dependency, yes, but it's made available for us to import wherever we need it. And now we can try it in our view. For example, we could simulate a simple lottery by making a range of numbers from 1 through 60, picking 7 of them, converting them to strings, and then joining them to a single string we can show on the screen. To be concise, this will need some code you haven't seen so much before, so I'm going to break it down as we go. First things first, change your current view so it has just text results. And that won't work yet, you haven't got results defined, but that's okay, we'll do it next. First, we're going to add a new property to Content View that will store a range of numbers from 1 through 60 for our lottery balls. So we'll say, let possible numbers be the range of, array of the range 1 through 60, like that. Second, we're going to add a computed property here called results, which will return a string. And this will pick 7 numbers from our possible numbers array and make them to a single string. So we'll have some more code here. Inside there, again, we're going to select 7 random numbers from our range up here, which will be done using the extension inside sample package. That's its job. This provides a random method that accepts an integer and returns that number of random elements from the sequence in a random order, so it's all shuffled up. Lottery numbers are usually arranged from smallest to largest, so we'll sort them as well. We'll start off by saying, let selected be possible numbers dot random 7 dot sorted. Give me 7 random numbers. Next, we need to convert this thing, array of integers, into strings. This takes just one line of code in Swift because sequences have a map method that lets us transform an array of one type into an array of another type by applying a function to each element. In our case, we'll pass in, our function is string.init. The initializer for strings, make me a new string from each number is what we're saying. So we'll do let strings equals selected.map string.init. At this point, strings is an array of string rather than an array of integers. And now, the last step is to join that array of strings together using commas. Now, there are a few ways of doing this. We can just say here, for example, return strings.joined separator, comma, for example. That's a nice way of doing it. There's also a list formatter or the formatted method. They all work here. But that completes our code. We can go ahead and run that code now. And all being well, we'll see our lottery results. There you go. If you use those and win, give me a slice, please. And there you go. So it just picks random numbers, stringifies them, and joins them together nicely, which is really nice. By the way, you can actually read the source code, such as it is for my package, right in Xcode. Just open up this little disclosure indicator here and choose sources, sample package, and then there's my Swift file here. That's the entire code we're working with. It's just a sample. It doesn't do much at all here. But that finishes the final technique required for this project. So please reset your code to its original form. Remove the sample package. You can get rid of this thing here. Go back to your packages and press minus for that, and delete it. Not need it anymore. Get rid of the import. Get rid of this junk, and then put it back to hello world with a little spot of padding, and then scrap this thing down